Today we're going to look at section 5.3, trig functions of any angle. So today we're going to use reference angles to evaluate trig functions. So using reference angles, we're going to be able to evaluate different trig functions. We're going to be doing this without a calculator. So knowing the signs of the trig functions and the reference angles are going to help us with this process. So if I ever ask you to evaluate without a calculator, here are the steps. We want to figure out what the reference angle is, because remember, our reference angle is always a positive acute angle. Once we have that positive acute angle, we're going to be able to draw a triangle in whatever the quadrant is, and we'll label the sides according to it. It's always going to end up being a special right triangle. So then once we know all the sides of that special right triangle, we can evaluate then for whatever the trig function is. All right, so we're going to use reference angles to find the exact value. If you are very familiar, so remember 30, 60, 90, 45, 45, 90. So let me sketch those for you again, but those are what you want to be very familiar with. So in general, remember in a 30, 60, 90 triangle, say the 30 degrees is there and 60 is here. Remember, they could be flip-flopped. The side that's across from the 30 is always the smallest. I'm going to call it 1. Then the square root of 3 would be the side that's across from the 60. 2 is the hypotenuse. Okay, once again, depending on which quadrant you're in, you could have some sides that are negative, some sides that are positive. The hypotenuse will always be positive. Remember, in a 45, 45, 90 triangle, because you have two congruent angles, that means that you have two sides that are congruent. So we always let the sides that are the legs be 1. The hypotenuse is the square root of 2. So once again, depending on what quadrant you're in, you could be dealing with your legs positive or negative, but your hypotenuse will always be positive. So those are the triangles we're essentially going to get to, but first we have to figure out the reference angle. So when you're dealing with a 300-degree angle, because when it's saying to evaluate the sine of 300, we focus first on just that angle 300. So if I was to sketch where that's going to be located, think about the fact that because it's a positive angle, we want to start at 0 degrees. We go then counterclockwise. So 90 degrees is here, 180 is right here, 270 is down there, and then we're back to 360. So where does 300 fall? Well, it's going to fall in between the 270 and the 360. So we are going to deal with trying to find this little reference angle right there. And so in order to do that, to find that reference angle, we are closest to the 360, because remember, you're either looking at the values of 180 or 360. You always want to look at the values that are on the x-axis. So because we're closer to the 360 in the fourth quadrant here, we'll do 360 minus 300, and that tells us that our reference angle is 30 degrees. So because this is a 30-degree angle, we always want to draw then our triangle to be perpendicular with that x-axis. So notice that we have a 30, 60, 90 triangle. So once again, the side across from the 30 is always the smallest side, but notice that that is moving down to get into the fourth quadrant. So I want that to be a -1. Because across from 60 is the square root of 3, and we're moving to the right in the first quadrant, to get to the fourth quadrant, we want that to keep that positive, and then your hypotenuse is always going to be positive. Okay, so then now that we have that special right triangle, we can use that reference angle, which once again is similar to where that 300-degree angle is, and we can now finish with finding what the sine is. So think about SOHCAHTOA. Sine means we want to do opposite over hypotenuse. So our final answer, the sine of 300 degrees, is us taking the opposite of 30, which is -1, over the hypotenuse, which is 2. I can't simplify that down any further, so -1/2 is my final answer. Okay, so that we started with a degree, but we still need to know and understand radians just as much. So notice that we have 5 pi over 4 as our radian value. So this is what I want to think about, and I want to try to figure out where is that located in my picture. Okay, so I am going to sketch a picture. Once again, because we are dealing with a positive angle, I'm starting at 0 radians. Remember, the full rotation would end up at 2 pi. So then cut it in half, going counterclockwise, we have pi. Okay, because I want to be thinking about that denominator of 4, okay, 2 pi technically over 1, we want to turn it into a denominator of 4, which means I had to multiply the bottom by 4, which means I multiply the top by 4. So really, 8 pi over 4 is 2 pi. So I'm going to actually erase 2 pi and think of it as that denominator 4. So it's 8 pi over 4. Okay, then that means that this is really technically 4 pi over 4, because notice 4 divided by 4 gives you then that pi. Okay, up at the top, I'm going to cut then in half between 0 to 4. I'm going to have then 2 pi over 4, which means that I'm going to be adding 2 pi over 4 every single time I go to one of those quadrantal angles. So 4 pi over 4, if I add 2 pi over 4, it gives me 6 pi over 4. And so because my numerator of that original angle right here is 5 pi, I definitely have it in this picture already drawn. So where is 5 going to be? If you're looking at the numerators, that means it's going to fall here in the third quadrant, this little angle. So how do I figure out that reference angle? Well, notice that reference angle, when I'm looking at my two particular values of either 4 pi over 4 or 8 pi over 4, because remember, we want to focus on the values on the x-axis, I'm closer to the 4 pi over 4. Because I want my reference angle to be positive, I'm taking the original angle that was given because it's bigger, and I'm subtracting that smaller angle of 4 pi over 4. So notice that pi over 4 is that reference angle. If you want to think of it then in terms of degrees, that's a 45-degree angle. I'm going to then draw that triangle perpendicular with the x-axis. So notice that we have a 45, 45, 90 triangle. So being in the third quadrant, both of those legs, which are the same value, are going to be negative because I move to the left and I move down to get to the third quadrant. The hypotenuse, though, is always positive. Now that I have everything in this picture, we can finalize this problem. It's tangent. If you think about SOHCAHTOA, remember tangent is opposite over adjacent. So that means that the tangent of 5 pi over 4, I want to take what is opposite of the 45 reference angle and put it over the adjacent. So that would be -1 over -1, and a negative divided by a negative makes that +1 is my final answer. Okay, continuing, notice that I want to find the secant of -pi over 6. So we want to start with looking at this angle. Right now, I see that I have a negative angle. In order to find the reference angle, remember, I want only positive numbers. So before I find my reference angle, I'm going to first find that coterminal angle. Okay, the positive coterminal angle. And remember, to find a positive coterminal angle means that you are either adding or subtracting pi over 2 or 360 degrees. So because we're talking about radians, I'm talking about wanting to figure out 2 pi in terms of that denominator. So because in my problem I have a denominator of 6, that meant that I multiplied the bottom by 6, which means I multiply the top by 6. So 12 pi over 6 is what I want to then, in this case, add onto my negative pi over 6. So negative pi over 6 plus 12 pi over 6 gives me then 11 pi over 6, where I want to then figure out what quadrant I'm in for my reference angle. So if I'm thinking about my picture, we're at 0 radians and we'll end at 12 pi over 6. Think about it, cutting that 12 pi over 6 in half, it would be 6 pi over 6. Cut 6 in half and you get 3 pi over 6. So that meant I'm adding 3 pi over 6 every single time. So 3 plus 6 gives me 9 pi over 6 down there at the bottom. So 11 pi over 6 is going to fall in between the 9 pi over 6 and that 12 pi over 6. So once again, I'm here in this fourth quadrant. So to find that reference angle, I am closer to that 12 pi over 6 than I am to that 6 pi over 6. So I'm going to take 12 pi over 6. I'm going to subtract 11 pi over 6. And notice that we then have a positive pi over 6, which, if you think about what it is in degrees, that's going to be a 30-degree angle. So I'll bring my triangle into this. Remember, I go straight up to get perpendicular with that x-axis. Because I'm in the fourth quadrant, one leg is positive and one leg is negative. Across from the 30 is the smallest side. It's negative because it's going down. That means that the 60 degrees is going to then have a positive side across from it, and the hypotenuse is always positive. So once I have that picture, now I want to focus on the secant of that reference angle, which we now know is 30 degrees. Notice that because we're talking secant, secant is going to be the reciprocal of cosine. And remember, if cosine is adjacent over hypotenuse, I want hypotenuse over adjacent. So the secant of negative pi over 6, the hypotenuse is 2. The adjacent side is the square root of 3. So I do have to rationalize this. I'm going to multiply the top and the bottom by the square root of 3. That gives me 2 root 3 over 3 as my final answer. Looking at the cosine of 17 pi over 6, notice that with my angle being 17 pi over 6 and that denominator being 6, it relates to what we just came up with in the last problem. Remember, one full rotation is 12 pi over 6. So yes, this is a positive angle, but we can actually find a smaller positive coterminal angle, and that's going to help us then be able to sketch the picture better. So let's take 17 pi over 6. Let's subtract 12 pi over 6. Notice that means that we want to sketch a picture at 5 pi over 6. So if I am starting my picture, we start at 0, we'll end at 12 pi over 6. Halfway going counterclockwise because it's positive is 6 pi over 6. Half of 6 would be 3 pi over 6. Then we'll have 9 pi over 6 down here below. But notice that the 5 pi over 6 is going to fall in between 3 pi over 6 and 6 pi over 6. So I'm over here in the second quadrant. Little reference angle right there. Notice that when you're looking at the particular values, you want to look at 6 pi over 6 and 12 pi over 6 to find your reference angle. 5 pi over 6 in the second quadrant is closer to 6 pi over 6. Since 6 pi over 6 is bigger, we'll do that minus 5 pi over 6, and that gives us pi over 6 as the reference angle. In degrees, that's 30 degrees. Going to drop down that right angle onto my x-axis. Because in the second quadrant, the side that is across from the 30 here is going to be positive because you're going up. 60 degrees, we're going left, so it's a negative root 3. Your hypotenuse of 2 is always positive. All right, now that I have my picture, we focus on using the triangle and the reference angle to find the cosine of 17 pi over 6. So remember, SOHCAHTOA, cosine is adjacent over hypotenuse. So the cosine of 17 pi over 6 is us taking adjacent, which is negative root 3, over the hypotenuse, which is 2. I can't simplify that any further, so there is my answer. So I would suggest that you pause the video and try without a calculator to find the exact value of each trig function. Okay, so notice the number 1, I found a smaller positive coterminal angle by subtracting 360 away from 495. That gave me 135, which then fell in the second quadrant. From there, I found the reference angle, which is 45 degrees. So I have a 45, 45, 90 triangle in the second quadrant. Cotangent, remember, deals with the legs because it is the reciprocal of tangent. So I needed to do the adjacent side over the opposite, and that's why my final answer turned into -1. Negative 22 pi over 3, I found a positive coterminal angle. Remember, I have to add or subtract 2 pi, which if I think about it, 2 pi turning into a denominator of 3 turns into 6 pi over 3. So I had to add 6 pi over 3 4 times in order to get to a positive value, which gave me a positive coterminal angle of 2 pi over 3. That fell in the second quadrant, which is closer to that 3 pi over 3 than it is to the 6 pi over 3. So that's why my reference angle turned into pi over 3. Remember, that's a 60-degree angle. Thinking about your 30, 60, 90 triangle, I was able to match up all the sides. Once again, in the second quadrant, one leg is positive, one leg is negative. Sine is opposite over hypotenuse, which is what gave me my answer, square root of 3 over 2. So that's us using reference angles to evaluate trig functions.